Hi everybody, welcome to part 2 of nuclear chemistry. Today, we will see how the atom got discovered and how the insides were theorized and discovered. And first, a person in ancient Greece said that the entire universe was made out of particles that cannot be broken. That was the origin of the atom, which was in fact correct. Now, in 1805, which is about in the 1800s, which is about 2,000 years later, a man named Dalton said that atoms cannot be split. The two same types of atoms have the same mass, color, shape, whatever else. 3. In a chemical reaction, the molecules and other things only change their partners. For example, here the sodium changes its partner of bicarbonate to chlorine. And here, a man named Gay-Lussac, another scientist, said that 2 hydrogens and 1 oxygen made 2 waters. And he said, in order for this to be true, there needed to be 2 hydrogen atoms, 1 oxygen atom, and the oxygen atom had to split. But according to Dalton's theory, the atom could not be split. So they added the big fight. But then, this is where Mr. Avogadro came in. Don't confuse it with the avocado, okay? He said, he's an Italian chemist, and he said instead of H plus O equals 2HO half, he said that there was 2 H2 molecules plus one O2 molecule, making 2 water molecules. But at this stage, they didn't even get full sense of the atom, and they only knew about the atom. So the molecule, they couldn't know anything about the molecule since they haven't got a grasp on the atom yet. So his theory, his theory was used a lot ever since he died. Too bad he didn't get to see his theory coming to life. Right? Okay, so later in 1903, a man named J.J. Thomson discovered the electron, and then theorizing the plum pudding model. If you don't want to know what a plum pudding is, for whatever reason, like you're not British or you don't like dessert or anything, you can just think of a chocolate chip cookie. That would be fine. But here, in his experiments, he did an experiment. First of all, he made an electric field inside of a vacuum. And then with the screen that detects electrons, which were discovered before he did the experiment. So, it detected the electrons. But when he put this obstacle in there, the signals coming to the screen were blocked. So, therefore, electrons must have a charge that this thing can detect. Next, he put this kind of swirly thingy just for fun. And then, the fan started to move. Therefore, electrons have mass and momentum. Next, he generated an electric field here with the positive and negative poles. Now, electrons have a negative charge, so after they hit the fan, they're going to get attracted to the plus side, making more on this side be shown, while getting less on this be shown. So he theorized a plum pudding model. Then why I put the pluses here is because atoms have to be neutral. Negative charges repel against negative charges, so you need positive charges for the atom to be stable. But then, in 1910, another chemist named Ernest Rutherford, made another experiment with radioactivity. Here, inside of a bottle made out of lead, he put in some radium. Now the lead would protect himself from all the radioactivity coming out, while the radium would be the source of the alpha particles. And then he collided it with some gold foil. Most of them just came straight through, but there were some particles that were directed the opposite direction. Therefore, he said that all of the positive charge in the atom is concentrated in some kind of small space. That's because, according to the plum pudding model, well, let me draw this real quick. The plum pudding model, if the positive charge would be coming here, it's just going to come straight through, or at least a little bent. But, like this diagram says, some of the particles directed the opposite direction. In fact, Rutherford even said there was like a bullet, you shoot it at tissue paper and then coming right back. And this is where the usual diagram from the atom comes in, right here. You see this kind of atom a lot, right? Well, he said that the electrons orbit around the protons, or the atomic nuclei. But, with his model, we cannot explain the stability of the atom. That's because, as the electron orbits it, it's gonna end up losing momentum or energy, and then eventually collide with the nucleus, causing a massive explosion. That's when Niels Bohr came in 1913. In 1913, he did an experiment using the light spectrum. First of all, H2 became 2H in this lamp. And then he used a prism and detected the spectrum, and turns out they were all lines. So he had to say that the electrons orbit in certain orbits. And that's the theory we use today. For example, this would be the K shell, or the lowest shell. And then there's the L shell, the next highest. Then there's the M shell, and so on. The N shell. And the ones closer to the N and Q shell, which is the outer shell, they have more energy and momentum. While the ones like the A and K electrons don't have as much momentum or energy. So, in other words, when an electron in the outer orbits get tired, they go into the inner orbits, while one of the electrons in the inner orbits will get excited and go into the outer orbit. Now, this theory also explains why fireworks work like this. If you're just confused about what this black flame reaction is, you can go back and watch the firework video. We needed a lot more views on that. Anyway, and then later in the days of 1926, a scientist discovered that electrons orbit around it in the clouds, which you will have seen in the part 1 video. So, the electron clouds are here, and then they bond, which then forms this bigger cloud, unlike the hydrogen atoms I drew here. And that's our show of Ethan's Laboratory. See you next time in Nuclear Chemistry Part 3. Thanks for watching, and bye!